What is up, guys? It's TimeForDillon back at it again with another crypto video. What is up, guys? It's TimeForDillon back at it again with another electronics tutorial. Once again, we are starting off with another lesson from the most complete starter kit of the Elegoo Uno R3. So in today's video, we're going to be doing lesson number 5, talking all about digital inputs. In the last lesson, what we did was we went over the RGB LED. It was a lot of fun. We basically wrote some code right here that made this sucker cycle through the RGB color band. It was a lot of fun. First time really pulling out the board, making things work. It was cool. But in today's video, we're going to take things a little bit further. We're going to be using some switches to turn on and then turn off the LED. So I'm super excited. Make sure you guys stay tuned until the end of this video so you don't miss out on this tutorial. Of course, first things first, what do we have to do? We have to go into our box and pull out the components. So what do we need? We need our Elgoo R3, the same breadboard we've been using, one 5mm red LED, one 220 ohm resistor, 2 of the push switches, and then 7 male-to-male wires. I like to scroll down just to see how they want us to wire it. So we're going to need 1, 2, 3, 4 black wires, 1 blue, 1 yellow, 1 red. Of course, the colors really don't matter, but I just want to remain consistent with this tutorial. So let's go ahead and jump into our box and pull out these components. So, like I said, we're going to need our breadboard, bingo bango. We are going to need, of course, the R3 Uno, blanca, whatever that means. We're going to need 1 red 5mm LED. Of course, it's in our cool little LED box. Boom, boom. Pull that sucker out, stick it right there. We're going to need some push buttons, which happen to be in the same exact box. 2 of them. 1 to turn on, 1 to turn off. So there's 2. Boom, boom. Just in case you guys didn't see, that's what it looks like. Pretty cool little sucker, ain't she? Ain't she a beaut? So go ahead, put this box back in there. Put that back in there. And then, of course, 1 220 ohm resistor. As you guys have seen, I like to save these. Some people like to throw them out after every use. I don't know. I'm not rich like that. So let's go ahead and get it. Boom. 220. Just stick it right in there. That's not where it goes, but I'm just putting it there just for funsies. And then, of course, our male-to-male wire jumpers. So I said 4 black, 1 red, 1 blue, 1 yellow, I think it was. Make sure you guys can see that in the camera. Cool. So let's go ahead and get these suckers out. Boom. While I'm doing this, I'll tell you guys once again about today's sponsor, nobody. So if you guys like this video, just hit the like button, because I don't have sponsors. This is just for funsies, onesies. So if you guys like watching, just stay tuned, support me just with a like, and tickle the algorithm, because that helps. Not that I really care, but you know, it's just fun to say that. Okay, and then we need 4 black cables. 1, 2, 3, 4. Boom. Let's go ahead and connect these suckers back up away, and we are done with our box. So we can get started with the lesson. Let's put this sucker to the side. Take a sip of a Pellegrino, why not? And get started with this lesson. Boom! So let's see. Switches are really simple components. When you press a button or flip a lever, they connect 2 contacts together so that electricity can flow through them, kind of like a light switch, right? The little tactile switches that are used in this lesson have 4 connections, which can be a little confusing. A, B, C, and D. Actually, there are really only 2 electrical connections inside the switch package. Pins B and C are connected together. Okay, so B and C are connected together. A and D are connected together. So these are the same, these are the same. Simple enough. Here's the schematic. So all of this is on the breadboard. All of this stuff. And then this, of course, is our R3 Uno. So we have a red cable, which is going to the resistor, going to the LED, going to D5 PWM, which we're going to have to look later. We have two switches, one going to D9, one switch going to D8. Those are connected together with a jumper cable. And then those jumper cables are connected to the ground. And then we have the ground connected to the LED. Okay, cool. And this is what that schematic looks like. Boom, 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 boom. Pretty cool. See, these are connected right here on this line, which is connected to this one. Boom. So the LED, both buttons are connected to the ground. We also have the positive side, it looks like, of the LED, which is connected to the resistor, which is connected to the power, it looks like. And then we have one switch connected to 9 and one switch connected to 8. Cool. Although the bodies of the switches are square, the pins protrude from opposite sides of the switch. This means that the pins will only be far enough apart when they are placed correctly on the breadboard. Remember that the LED has to have a shorter negative lead to the left. Okay, so let's get busy with the wiring. Boom. So I'm just literally going to copy this wiring diagram. So set this over here. Boom. So it looks like we're going to put the LED. And let's see if we can zoom in here. You guys can kind of see it right here. Boom. So we have, this is number 20 and this is number 25. So 20, 21, 22 is where the LED is. So if we rotate this, 22, 21, right? 20. That's 20, 21, 22 is where it starts, and it's one down. So it's right here. We have the positive, not on that side. All right, we actually have it like that. You can see. So, one down, right there. Boom, just like that. So if you can see where it is, it's on the second row. So not the first row, the second row, and it's 1, 2 down from 20. Cool. So now what we need to do is put our resistor. So it looks like the resistor is starting on the positive side and then going 1, 2, 3, 4 down, and it's 1 down. So just like that, you can see. So the resistor starts where the positive leg is for the LED, just 1 down, and then skip 3 holes, boom, same line. Cool. So now what we need to do is we need to connect the jumper cable, and it looks like it's in the same hole as the negative leg, so we're just going to literally copy it. Same hole as the negative leg. And then this jumps over, same exact line. Boom, right there. So just like that. Make sure it's on the same line, which it is, if you take a look. It's on the same line. Boom. What I'm going to do is, I'm going to do this red wire first. So it looks like it's on the same leg as the resistor, but just 1 down. So right there. And then this is going to be connected to our R3. So we'll just leave that like that, which will help us see where the switches need to go. So the switches is just down 1 and over 1. And what's cool is these will only fit one way, so you can't put it the wrong way, which is pretty nice. So if you try and do it this way, it's not going to reach. So you have to do it this way. It's the only way it's going to work. Boop. And just stick it in there. Boom. So it only fits one way. That's the way it needs to go. And then, of course, we got to put the other one. So just one line down. Boom. One line down. Same thing. So just skip a series of lines. Jam that sucker in there. See? So it looks like that. Now we need to use our jumper cables. So jumper cables, what they're going to do is on the right side of our button, one box down, whoop, right in there, and connect it with the same line that our black jumper cable is on. Make sure it's on the same exact line. Because this is all of this is our ground. And same thing with the other button. So same exact thing on the right legs. Boom, one down. Jump it on down to right there. So when you're done, it should look like that. See how all of these are on the same line right here? Make sure that they're all in the same line right here. And now we need to connect our blue and yellow wires. So our blue wire goes on the left side of the left button. And then same thing with the yellow with the other button. Right there. This last cable needs to go in the same rail that all of these black cables are on. So you could literally put it down here. It really doesn't matter. It just needs to be on this same rail because all this rail is connected. And all of this rail is going to be our ground. But we're just going to stick with the schematics, put it right there on the same line. So now all we need to do is just connect it to our R3 Uno. And it's going to go on the side with the 9, the 5, and the 8. So it's going to go on this top side right here. So the black one goes into the ground. If you take a look, you can see we have our ground, we have our 9, our 8, and our 6. Or sorry, our 5. So black is going to go to the ground. Black to the ground. Blue to the 9. Yellow to the 8. And then red to the 5. Boom. So when you're done, it should look like this. You can see. Cool. And we are ready to plug this sucker in. So let's carefully push this over here. Plug this sucker in. We'll leave that there even though it's on. Let's jump back to our PDF and see what's going on. And now let's jump to the coding part. After wiring, please open program in the code folder lesson 5 digital inputs and press upload. Okay, so to do that, just like we did in yesterday's tutorial, wherever you put the PDF for the instructions, whether you got it from the CD or you downloaded it from the internet, wherever you put that file, that is where we need to go. So for me, I happen to put it right here on the desktop. Just double click, find your language, English, code. We are doing lesson 5 digital inputs, so it's right here. And there's only one file in there. We can close this, we can close that, and we can make this just a little bigger. Bingo bango. Load the sketch onto your Uno board. Press the left button will turn the LED on. Pressing the right button will turn it off. Okay, perfect. So let's go ahead and do that. So make sure you select the correct board, go to your port, make sure it's on the correct port, and then we're going to click upload. Let's switch to our other view so we can see what's going on. It flickers a little bit. And here we go. We are loaded. So now when we press this left button, when we press this button right here, it should turn the LED on. Oh, cool. And when we press the right button, it turns it off. We press the right button multiple times, nothing happens. If we press the left button multiple times, it doesn't do anything. Cool. Very cool. So this actually works. Let's take a look at what our instructions are saying. Load the sketch onto your Uno board, press the left button, and we'll turn them. Okay. The first part of the sketch defines 3 variables for the 3 pins that are to be used. The LED pin is the output pin, and the button A pin refers to the switch nearer to the top of the breadboard. The button B pin is the other switch. Okay. So int LED pin is 5. So if we actually look at our board, the ground came out. The ground came out. Don't do that, people. But if you take a look right here, you can see that our LED pin is 5, our button A pin is 9, and our button B pin is 8. And if you follow the wires, so button A pin, which is the pin that will turn it on, should be connected to 9, which is where our blue cable is. And if you take a look, the blue cable goes right here next to the button that we press to turn it on. In our code, button B pin is connected to 8. So that's the yellow one. But because in our code, button B pin is the one that turns it off. And as you can see, the yellow pin goes to our button B pin, which turns it off. So on, off, on, off. Pretty cool, right? And that is consistent with our code. Very cool. So the setup function defines the LED pin as being the output as normal. Output. Because that's the pin that goes to our LED, which provides the power to the LED. But now we have 2 inputs to deal with. In this case, we use the set. Set the pin mode to the input pull-up like this. Button A pin input pull-up. The pin mode of input pull-up means that the pin is to be used as an input, but that, if nothing else, is connected to the input. It should be pulled up to high. So with the digital write function, it seems as though it's taking in 2 parameters. It seems as though the first parameter is tied to a certain pin, and the second parameter is tied to either high or low. High meaning on, low meaning off, or high meaning send some electricity, B meaning don't send electricity. So that's what the digital write function looks like it's doing. So when we tell it the LED pin, we're saying at pin number 5, which we just saw was the one that's connected to our LED. When we tell it high, that means to turn it on or send some electricity. When we tell it low, it means don't send any more electricity. And it appears as though the digital read is kind of a little different, meaning when it receives a low signal, that means that the button was pressed. So it's a little different than high and low from the digital write function. The digital read low means it had an action, and the action was it was pressed. So a little different. In the loop function, there are 2 if statements, one for each button. Each does a digital read on the appropriate input. Remember that if the button is pressed, the corresponding input will be low. If button A is low, then the digital write on the LED pin will turn on. Similarly, if button B is pressed, it's going to send that low signal. So digital write is different from digital read. Just make sure you pay attention to that. The write, high means on, low means off. For read, low means it was pressed. Well, that's all we have for you guys today. If you guys made it this far, pretty awesome. You guys were able to turn on and off your LED, as you can see. Bing, bong, bing, bong. Lesson was pretty simple, pretty straightforward, but it shows you how to use these buttons, which will definitely be helpful in the future. You know, if you want to do certain tasks with your circuit board. I don't know, I'm just thinking of projects that we're going to build in the future once we're done with these lessons. But if you guys made it this far, you guys are awesome. If you guys want to tinker with this, tinker with it. Show me in the comments what you guys were able to do. I'm very interested to see. But in our next lesson, what we're going to do is make a buzzer. This sounds pretty cool. We're gonna have a buzzer, we're gonna have some wire cables and the R3, and it looks like we are going to be making some sounds with some code. So I'm pretty excited about this next lesson. If you guys made it this far, you guys are awesome. Smash the like button, drop a comment down below, subscribe to the channel if you guys are here. So if you guys like what you saw, make sure to follow along. But you guys have a beautiful day, beautiful night, wherever you guys are. Dylan is out.